Hello, Lana. How do you do? Welcome to Manifested Online Classes. We are going to proceed ahead with our topic, longitude and latitude. In today's lesson, we are going to look at speed in knots and speed in kilometers per hour. So, Lana, it is speed in knots and speed in kilometers per hour. The main objective of this lesson is to enable the learner to catch up or get up the difference, to get the difference between or the relationship between knots and kilometers per hour. It is to enable this learner to get the difference between the two. So to get these, we start from very elementary things. On a great circle, 1 degree subtends 60, an arc of 60 nautical miles on a great circle. So the reason on a great circle of radius r, one degree subtends an arc length of 60 nautical miles. 60 nautical miles. So this, we can get this distance in kilometers, then we get the relationship first between the kilometer and the nautical mile before we move to the knot. So therefore, this distance in kilometers, because this is 1 degree, so a complete rotation is 360. It is 1 over 360 times 2 pi r. So in this case, you take r is 6,370 kilometers. You'll take the radius of any great circle on Earth to be that. So you'll come and work out. This is 1 over 360 times 2. Take pi to be 22 over 7 times 6370. So you'll work out 7,910. 2 there once, 2 goes there, 180. So if you work out that, it will give you 111.222 kilometers. So 60 nautical miles, it will mean 60 nautical miles is 111.222 kilometers. So it will mean 1 nautical mile will be 111.22 kilometers divided by 60, which gives 1.853 kilometers. So from our working, 1 nautical mile, Lana, is 1.853 kilometers. From there, it is very easy to relate these. So you are told 1 knot is equal to 1 nautical mile per hour. 1 nautical mile per hour. But 1 nautical mile, we've seen, is equal to 1.853 kilometers. Therefore, 1 knot is therefore equal to 1.853 kilometers per hour. So learner, there you'd have derived the relationship from the very basics. On everywhere on Earth, any great circle subtends 60 nautical miles. Any great circle will have radius r, 6,370 kilometers. So from there we get the relationship between a nautical mile and a kilometer. But we are told 1 knot is equal to 1 nautical mile per hour. But 1 nautical mile is 1.853 kilometers. Therefore, 1 knot is 1.853 kilometers learner. So straight to an example where we shall apply that. So learner, that is the question. A ship sails due east from an island A, 48 degrees north, 42 degrees to another island B. The average speed of the ship is 27 knots, 27 nautical miles per hour. And it takes 22 hours to reach island B. Find the distance between the islands in nautical miles and in kilometers per hour. The speed of the ship in kilometers per hour, and C, position of island B. In short, they are asking you for that. So before you move on, you'll note that if it will move east, it will still be on the same latitude. It is only the longitude that will change. So you come to solution A, distance in nautical miles. So if you are given the speed, here you learn that 1 nautical mile, 1 knot is 1 nautical mile per hour. So you'll just come and say speed, distance, is equal to speed times time. The speed is already given as 27 knots. 27 knots, which is 27 nautical miles per hour. 27 nautical miles per hour times 22 hours. So learner, on working out that, you'll get 594 nautical miles. Nautical miles. And having got this relationship, 1 nautical mile, 1 nautical mile is 1.853 kilometers. So in kilometers, learner, it will be 594 times 1.853. That will give you 1,101 kilometers. 1,101. So you'll come to B, speed in kilometers per hour. So there are two alternatives. B, alternative 1. Alternative 1, you just convert the knots to kilometers per hour. Convert the knots in kilometers per hour. So alternative 1, you take 27 knots times 1.853, and you'll get, it comes to 50.03. Alternative 2, you'll actually get the distance divided by distance divided by time. Distance divided by time. You'll take 101 kilometers. You divide by 22 hours. You'll still get 50.03 kilometers per hour. So check learner. In the first one, you just change directly from what we derived there. You just change. In the second alternative, you get the actual distance in kilometers and you divide by the time which was given. When we come to C learner, when they talk of position, we learned earlier to give the definite position of a place, we should state the latitude and the longitude. Given that the ship moved due east, it still retained its what? Its latitude, but the longitude changed. The longitude changed. So the ship retains its latitude, but the longitude changed. The longitude did what? It changed. So we have to find out how to get that longitude. Number one, you realize that the ship is moving on a small circle. So if I have that, the ship with that as the equator, you'll find 48.7 degrees. This is a small circle. A small circle. So we actually have that small radius. We shall talk of a small radius. This small radius was given by what? R was given by R cos theta. R cos theta. So, but in this time, to get the longitude, longitude difference, so you'll come and say distance will be given by longitude difference times 60 because 1 degree of longitude is equivalent to an arc length of 60 nautical miles. So this longitude difference you get is the one that you'll substitute to get the new position of B, because I've said the latitude remains 48.7. So I'll come here. So I'll decide to use nautical miles or whatever I have. I'll go to the first question. That is 594. 594. So I'll say, I can denote this one as x. I'll call that x. So 60x. And since it is a small circle, I'll have to multiply by cos theta. Cos 48.7. Cos 48.7. Cos 48.7. 60x times cos 48.7 will give me 594 nautical miles. 594 nautical miles. So x, therefore, x will be 594 divided by 60 times cos 48.7. So that gives you 15 degrees. 15 degrees. So the longitude difference, the longitude changed by 15 degrees. So we'll come and say, so the new longitude, so the longitude changed by 15 degrees. 15 degrees. So we'll come and say position of B will be, since it has retained the latitude, it will retain this latitude. The difference, the latitude remains the same. So it will be 48.7 degrees north. Then you take plus 42 degrees plus 15 degrees because it was sailing to the east. It was sailing to the east. So it will give you the new position as 48.7 degrees north and 57 degrees east. So that will be the position of B. That is the position of B. So learner, having gotten that, we shall go straight to this assignment. So quickly through the questions. 1, a ship sails due east from X 20 degrees north, 60 degrees west through 25 degrees of longitude to a point Y, and then sails 4,500 nautical miles due south to a point Z. Find the latitude of Y. B, calculate the distance sailed from X to Y in nautical miles and find the latitude and longitude of Z. 2, find the shortest distance in nautical miles along the surface of the earth between places P, 75 degrees north, 105 degrees west, and Q, 75 degrees north, 21 degrees east. What will be the time at Q when it is known at P? Those two questions will give you enough of the practice on those questions, on the topic when we come to longitude, time, and even knots. So thank you very much. Work through the assignment, and let's meet in the next lesson. Thank you, and bye-bye.